Every year, 2.2 million people die from pneumonia every year. They're usually diagnosed through x-rays. Knowing that, I have a challenge. Does the left or right x-ray have pneumonia? If you guess the right x-ray, you're correct. But in order to accurately and constantly diagnose pneumonia, you often require trained medical professionals. But what if I told you, yes you, using Python and its corresponding frameworks, you were able to diagnose pneumonia at over 90% accuracy? So before we get started, here are some requirements. You need a Google account, experience in Python, and that's it. That's all you need to do to create an AI that's able to accurately diagnose pneumonia. Okay, here we are in Google Chrome, and let's get started. The first thing we need to do is we need to go to colab.research.google.com. And this will take us right here where we can create a new notebook. This is where we'll write all our code and everything that we need to run our program. So this episode is going to be about downloading and setting up our data so we can train a model on it. So first thing, we'll name our thing Pneumonia notebook. And then the first thing we need to do is we need to connect to a runtime. So I'm going to connect to a GPU. And the reason why we're doing that is because we need to use a GPU in order to train our model. It's faster than using a CPU. So let's do that. Let's go ahead and connect. Okay, now that we're connected, the first thing we need to do is we need to download our data. So the way we need to do that is we're going to import a few important things. We need to import OS, import pathlib, and then we'll also import zip file, and we'll import URL library.request. And after that, we're going to go ahead and run that. So now we have pretty much everything we need. Next thing we're going to do is we're going to set up our data directory. So we're going to create a path. So we're going to do pathlib.path. I'm just going to call that data/pneumonia. So once we do that, let's make our directory. So we're going to do data_dir.mkdir. Parents is equal to true. And then exist, okay, also equal to true. After that, we're going to get our URL. So you may be thinking, how are we going to use URL? And we need to get our data, which is going to be a bunch of images of x-rays, and some have pneumonia, some don't. And we're going to go to GitHub over here, and I actually posted our data set on GitHub. I'll provide the link. So we're going to go to our archive.zip here, and then we're going to go here. And then we're going to click on raw. So you see this raw, it'll download, but we don't want to do that. So we're going to right click here. We're going to right click and then copy link address. And we're going to paste that into our URL. See, that's great. After that, we're going to need to create a path for our zip file to be located. So zip path is equal to data directory. And then we're going to set that as just, I don't know, archive.zip, I guess. And then after we check if not zip path.exists, then so in this case, if our zip path doesn't exist, then we need to go ahead and download our data. So we can put just downloading, and we do URL library.request.url retrieve, and then we need to retrieve our URL, and we just send it over to our zip path. And then we're going to print finished downloading. I'm not going to capitalize, I don't really care. Okay, so once we're done with that, we need to actually unzip our zip file. So we're going to do with zip file. We're going to address it to our zip path, and we're just going to read it. That's all we're going to do is read. And we're going to do as zip ref. There we go. And we're going to do zip ref.extract all. We can extract all data here. And then after all that's done, we can just print data set extracted. Let me just go ahead and add that in. There we go. So now let's go ahead and run this and see if it works. Oh, well, that's one thing. Pathlib pathlib has no attribute path. That's because I didn't capitalize the P. There we go. So it's downloading our dataset. And just keep in mind that this doesn't download to your machine, it downloads to Google Colab, so you won't lose any of your data. So, you know, all of your data space. Alright, everything's done. I had a few grammatical errors, but we can ignore that. Let's go ahead and click on this button right here so we can check out our data. You don't want to click on sample data, that's something Google Colab gives you, you don't want to touch that. I'm going to open up our data, it's going to take a while to open, and then we have pneumonia, as you can see, that's our data there. Open that up, you can see, this is our archive.zip, we can go ahead and delete that, we don't need that anymore. And let's open that up, and you can see we have a test, a train, and a validation. So in machine learning, you train your model on this test data, and you test on this, and then to finish everything off, you sort of validate your model, see if everything works fine using this. If you open that, you see you have normal, and pneumonia, and the model's job here is going to be, okay, I have a chest x-ray, is it normal, or does it have pneumonia? That's all you gotta do. So you can see, let's open this up, you can see you have a bunch of images, let's open one of them up. I think we'll download it and just check it out. Hold on. We download it, let's open it up. As you can see, this is a chest x-ray, and everything here is also going to be a chest x-ray. Okay, so now that we have everything downloaded, it's time to actually get this stuff into Python. How can PyTorch is what the library we've been using. How can PyTorch access this data? So the first thing we need to do is going to import Torch. Once we import Torch, we need to use Torch Vision. So from Torch Vision, import, we need data sets. And then transforms. After that, we're going to do from torch.utils.data import data loader. Okay, so the first thing we want to do is we want to create something called a transform. This tells PyTorch how do you want to change your image so a model can take it in. So we'll do transform is equal to transforms, and you can see that's what we imported right here. We're going to compose a transform. Going to be a list right here. Let's open up that list. First thing we want to do is we do transforms.resize, and the sidebar image is going to be 224 by 224. And the reason we're doing this is because we want every single image that our model takes in be the exact same image size, so we don't run into any shape errors. And also we do this specific size because it's optimal, because it's low in data, so it doesn't make it too long to train, and it also has a lot of info in it. You don't lose any information in the image. And the next thing we're going to do is we transforms.grayscale, and then channel, set that to 3. This just turns our images to grayscale so don't waste too much computational power. And the last thing and most important thing, we do transforms.toTensor. Now this actually converts our image into numbers, so PyTorch can actually train a model using that data. So the next thing we need to do is we actually need to set up our actual data. So first we need to train dir. Remember this little data dir? We're going to use that data dir, and you can see data dir is right here. And then we're going to go into pneumonia. We're already in pneumonia, and then we actually need to go into chest x-ray. So / chest x-ray. Now we're there. And you can see after that now we have train and test. So we're actually going to do access train. And do the same thing for test dir as well. Okay, so test dir. And go over here, replace out test. I don't know why I ran that, but that's it. Okay, after that, we need to go ahead and actually make our data sets. So we're going to train data set, and we're going to set that equal to data sets. Remember what we imported here, .image folder. You can see, hold on, root. So that root is going to be our train dir. And then after that, our transform is going to equal to our transform that we made here. Now let's make the exact same thing for our test data set. Let's read the test dir. And then we'll set, instead of training, test data set. Great. So I'm just going to run this for a bit, and then we're going to do train data set. Let's just get the length of that. Let's see, 5,216. Now test data set is 624. Perfect. So now we have our two data sets, but the problem is we need to create something called data loaders. This makes it more efficient for the model to, infer and train. Okay, so we're going to do train data loader is equal to data loader. Remember what we imported up here? And then after that, we're going to set our data set to train data set. And we're also going to have a batch size. So this actually says, okay, every time we train, we're going to give the model a batch of images. That makes it more, efficient to train. Here, 32 is probably optimal, so that's all we need. And we're going to shuffle our data as well. Okay, let's again do the same for test as always. Let's not shuffle it this time. We don't usually do that. And instead of train data set, we'll do test data set. And instead of train data loader, we'll do test data loader. Great. So now we essentially have everything. Go ahead and run it. No errors. Perfect. Now the last thing we want to do is we need to visualize our data, because we need to make sure everything looks great, everything looks fine. So we're going to import matplotlib.pyplot as plt, and what that lets us is lets us plot our images. So that's pretty useful. So first thing we're going to do is we'll just get an image. Actually, let me just show you guys what first. So train dataset. You can index a train dataset. If you index that, you see you get a tensor and we get a label. 0 means that it's pretty cool. 0 means that it's normal, and then 1 would mean that it's pneumonia. Okay. So let's go ahead and just plt.imshow, and then we'll do train dataset. And then if we just do 0, it's going to be a tuple, so we need to access this first element over here. So we're going to do 0, and we can index that again. You can see invalid shape 3, 224, 224 for image data. See, what happens here is that PyTorch actually likes using the amount of channels here first, but matplotlib actually wants to use it last. So we do something called .permute. And after that, this is the 0 and the 1 and the second index. We'll put the 0 here and then the 1 here. We'll put, actually no, my bad. We'll put the 1, the 2 here. So we'll have 224, 224, and then we want the last one, the first one here last. So .permute 120. Let's see if that works. As you can see, we finally are able to see, the image. So first, let me just do plt.title, and then we'll do train dataset 0, and we'll index at 1 just to see if it's normal. You can see, so it's 0 here, put a semicolon there. You can see it's 0 there, and then let's actually see if we can find an abnormal image. So I'm going to import random. Let's just shuffle through a bunch of images. Random.rand int, and then we'll just put in the length of train dataset. And then let's copy that. Actually, no, we need to set this as a variable because it's gonna. Let's set this as a variable. So the idx set equal to that. There's that. There we go. After that, let's delete this, put in our idx. And let's just shuffle through a bit, see if we can find something. Hold on, we can put 0 here. There we go. Let's go ahead. Oh, there we go. We find one with pneumonia, you can see. Let's see if we can find the difference. Let me just copy this ahead. And then replace this with 0. We all know 0 is a normal one. Oh, 0 is gone. There we go. So as you can see, can you detect a difference here? I personally, I can't really. So in the next video, we're going to create a model, and we're finally going to train that model. So you can see it'll receive an image and it'll say if it's normal or abnormal. I hope you enjoyed this video. I'll see you in the next one.